Hello, welcome back. We're outside again, so it's a bit noisy. It's a beautiful day, so I'm outside. That's why I'm recording outside as well. It's just easier for me. Where are we with BlitzBASIC to PlayBASIC? Well, we've been working on the dimensioning support here in Magpie in the background. So we'll give it a run in debug mode. So information is a bit different than what it was before, but not much all that interesting. This is our resulting code. So I'll sort of pick through this. Well, actually, I'll pick through the original code and we'll go through what the converter supports. But that actually does compile now in PlayBASIC. Here's the original Blitz code. So in Blitz, our main changes are going to be the field keyword here is obsolete, so we don't need that, and we have an end type keyword rather than end type keywords. So those changes have been made for us. The dimension statements are basically the same. There's nothing different about those. Well, there is, but we'll get to that in a second. In Blitz, we also have an integer postfix, which is the % symbol. So in PB we don't have that, so we have to remove those, which is what we do in our translation. Float's the same, string's the same. Now, Blitz has a support for stacked arrays, and I thought I added this. Wow. This came up during the Amos conversion stuff, because Amos supports the same thing, but haven't. And you can also do it with typed arrays. Notice the different syntax here, this inverted syntax. And here I'm just testing whether you can have complex expressions inside the dimension statement for the field size. If I just grab these couple of lines here, which are the ones we want to look at really, the rest of it's all pretty much for muchness. We go to the translated one, which is this is the one. Yeah. So you can see what the converter's done is it's looked at this first line. I'll put the original lines beside them. So this was the input line. Sorry. This was the original input line. This one was the other original input line. The one at the bottom there was the other one as well. Let's comment them out. So in the first case we've got a stacked dimension, a stacked array dimension. We've got array 1 integer type, and then we've got a second dimension on the same line. To do that in PB we've got to substitute this comma with a dim colon. So we keep the things on the same line, but we're inserting the statement to allow us to phrase this and act the same. When we have a type, we've got to rearrange the expression. So when we find this declaration here, we're going, okay, array 3, alright, cool, as of this type. And we've got these brackets here, so we need to rearrange these back into here and replace our dot syntax with as, which is what PB accepts. And because they can be stacked, we need to do the same thing through here. And the last one has an expression inside those things to show that we can unlink these tokens from in here, a more complex expression, and move them back without damaging it. I hope not anyway. I'll just try and run this one here and debug. We don't get any output because there's just nothing it's doing, but we can see what arrays we have. We've got array 1, which is our integer array. Array 2 is fine. A typed array. Yeah. We're getting no allocated types because the array's been declared, but the individual types within it are not created until we actually do a new of them. Our float array look good, and our integer arrays look good as well. So it's all working. So I've been doing this smaller subset testing to these larger ones. I haven't tried the bigger source code for a few days actually. this won't produce anything that's useful. Like at the moment, our converter is catching these dimension statements and phrasing out what arrays we need are within them, but it's not storing this in a list. We need that because as we go through the code, like these are the declarations, but when something's been used, like if we go print, was it array 1 or something, L5, position 5 or something, plus I think it was, I used I in front of them, 10, let's say. At the moment when it's phrasing through, it'll pick up these statements, but it won't understand what these keywords are. So if it's an integer array like that, no dramas, it'll get spat out the same way it went in, because there's no translation required. But if that's obviously one of these float arrays, for example, or the int array up here that was declared with the, it's been removed in this example, with a symbol added to it, and that keeps popping up later on in the code, we'd have to remove those during our translation. So we have to skim through, find this keyword and go, alright, what's this word mean? Look it up within our current scope, which is what we also need to do, is keep track of, are these arrays global, are they local? So we sort of have to do that. And once we do that, we should be able to get a pretty good, not a great translate. Well, I think pretty good is about the best we can hope for. It'll be better than doing replacements, but it won't give you full out working code out of the blocks. You'll find some expressions that it won't understand, or that I've not considered, that it just has no clue about what to do with them. To make this line here PB compatible, we'll have to remove these percentage symbols. Or as I was saying before, if you go dim, my strings, maybe a size of 100 of them or whatever, in Blitz you don't have to use that the postfix symbol, so it's not baked into the name. With PB it kind of is baked into the name, so it's okay to do stuff like this in Blitz. Run through and print out all the strings or whatever you want to do. When we look through this to convert it, we'd have to look for my string, check is my string declared within our current scope. If it is, then we look at the symbol following that and we go, okay, this was originally declared as a string array and we're not using the string, so we better output this to make it compatible with PB. Otherwise PB would just assume it would just assume this is an integer version of that array, which is going to cause problems. But hopefully if we can catch that kind of stuff, catch a lot of the type field, the backslash stuff, and types won't work out of the box, but we'll get a lot of the clunky syntax stuff worked, and hopefully you get these variable and array problems solved, and that'll actually go a long way to you having a working program. When I started this the other day, I thought, well, if we can get to a point where it can solve 50% of your problems, that's pretty good, because on these large code bases, that's hours and hours of work. And for some programs, if they don't use things outside of what it understands how to solve, that'll be fine. You'll be able to paste them in, convert them, and get something that's probably 90% ready to run. That's where we are at the moment. Anyway, we'll just give it a go with that the longer source code. Just see how long it takes. Should be a lot slower now. Should be. This is the GUI code. Just run it, not in debug, but run it straight out. we're a fair bit slower, so with phrase times 325 and the convert times about half a second. So we're almost at a second to do a pretty full-on. We're not fully compiling the code. Obviously, we're kind of picking through and looking for things that we're interested in, and then when we find them, we're replacing those things. We'll run it again to see if we're under any stress doing that. Yeah, I thought as much. So about half a second to load it and tokenize it and output it. That's pretty acceptable for a 9,000 line. 9,000 lines of code, 87,000 tokens to run through in just PB. Now that's not going to produce working code. It will take ages. We'll try in debug mode. We've got a lot of debug dumps at the moment, so we might get stuck here for a little while. So it took a lot longer because we've got a lot more stuff being spat out to the console. Every time it finds a variable, what it thinks is a variable, it's going to spit out this little message. Because it's also doing a very preliminary version of detecting variables, but it's not remembering them at the moment. So just look at the start of that function. We'll just see if we've done some replacements of that. Well, there you go. So we've actually made a working replacement. This is the menus GUI that was in. Now we've converted to something that's compiles and will run straight out of the box in PlayBASIC. Those 5 lines there have been converted perfectly. These lines here won't be. That's our next port of call with arrays, is to catch these situations here and then rearrange the expression suitably. We might have to put warnings on some of those there too. Like if we know something's not being converted correctly, then we should warn the end user that, hey, this line's broken, come and fix it. We've got some chicken before the egg stuff here as well. We've got arrays that are typed being declared before the types are being defined. You can do that in Blitz, you can't do that in PlayBASIC, so that code won't build anyway. But syntactically, we're closer to something that's that will work. We haven't even started on, once we get arrays and we get variables done, it means that programs that just use arrays and variables will port with a high degree of certainty. But we have to have emulations of Blitz functions. So this in our GUI example, we've got this wrapping code. Where is the code gone? There it is. Sorry. This thing called Blitz Wrapper, which is a list of just functions I'm emulating in PlayBASIC code that do what Blitz does. Sometimes they're just namesake wrappers like that one there. We could substitute this for that and life would go on straight away. These won't be, because I know Blitz has different ideas about how images work. But for the most part, we'll be able to build a wrapper of these commonplace functions, and commonplace stuff will work straight out of the box. Well, has a high degree of possibility of working. It's the best we can hope for. Alright, thanks for listening to this, and sorry for all the car noise in the background. I'll catch you next time. Bye.